All right, so I'm going to start right on your day 3 problems, and there's going to be a lot of omissions on this sheet as well, because again, we didn't do logs with you guys because you have such a big foundation from your work in Algebra 2. So we don't really tend to do those in this course too much anymore. So I'm going to start right with number 1. Number 4, that entire column can get crossed off. So you are not responsible for those anymore. And number 1, you are given vectors and you're looking for a dot product. So this is a formula, nice and easy, but it's not on your formula sheet. So what you need to know is that you're going to go x1, x2, plus, bless you, y1, y2. And then you're going to just get your product from this. So I would go -8 times the 4.5. And then next, I'm going to go plus 2 times 18. So left side is -36. And the right side happens to be +36. So this adds to 0. So do you guys remember, are these vectors perpendicular? Yes, because they sum to 0. So that's it. So yes. Reasoning, your sum equals 0. So your dot product sum from above. All right, again, this whole column you can omit. So if you need any of that space, feel free to use it. So next, number 2, find the cross product for the vectors. So this is when you're going to set up all those determinants. So this one you might need a little bit more space with, but again, feel free to use that side. So I'm going to go little I, little j, little k, and then I'm going to take my vectors here. So I have 5, and then 2, -1, and then 2, -4, and -4. And then what you're going to do is find all of these determinants. Okay, and we'll write your answer as the ordered triple notation, and we'll do it as a sum of unit vectors as well. So I'm going to go I. And then what you do is you're going to cover up that column, cover up that row, and your resulting determinant is made up of 2, -4, so 2, -4, -1, and -4. I guess I'll write all these out first. So next one, you're going to switch your sign and you're going to go -j, and then you're going to go cover up that row and this middle column. So I'm going to go 5, and then 2, and then -1, -4. And then lastly, you're going to go the little k. So I'm going to go plus your little k here. And you're going to cover up that row and column. So that would give me what? 5, 2, 2, and -4. Okay, now you're going to find your determinants. So I'm going to take the I, and I'm always going to start right on this leading diagonal right here. So we're going to go -8, and then minus, and then -4 times the -1 is going to give me 4. Next, so minus the j, and then I'm going to go -20. And then minus that -2. And then next I'm going to go plus the k. And I'm going to go -20 minus the 4. All right, so almost done. So I have I times the -12 here. So this is a -12I to begin. And then I have positive 18j because double negatives in there. And then I have lastly minus 24k. This notation is what we refer to as the unit vector notation. So it would be totally acceptable on this one to leave your answer like that because I didn't specify otherwise. Or you can write this as your ordered triple as well. So ordered triple would be -12, 18, and -24. And again, that is the notation that's referred to as ordered triple. All right, how are those first couple, okay? I think the whole rest of this front we cross off. Yes. Cross off the whole rest of the front and over to the back side. And this is absolutely where you want your formula sheet in front of you. And you're gonna draw your attention to the left-hand side of that. So this is talking about a toy rocket that is launched at an angle of 80 degrees, and it talks about velocity. So with your velocity, if you guys look at your formula sheets, and if you look at the third box down, it's gonna give you, I'm gonna just rewrite this a little bit because I like to do it like this. Cos theta times t. And then it's also gonna give you your formula for y as well. All right, so that one I've got velocity, sine theta t, and then plus 1/2. And then that goes gt squared and plus h if you have it. Most of the time you don't. Okay, so we're gonna use those formulas right there. So you have an angle of 80 degrees with a horizontal initial velocity of 80 feet per second. How long is it gonna take for the rocket to be 10 feet horizontally from its starting point? So I'm gonna grab this formula. So I'm gonna go 10 is equal to, and I'm gonna go 80 because it's already positive, and then cos, and then 80, and then times t. And then to solve for t, all you have to do is divide. So did we already check calculators were in degrees? I think you guys did, right? Okay. So as long as your calculator is in degrees, you're good to go here. So you're gonna divide by 80, cos 80. So 80 cos 80, divide by 80 cos 80. Let me see how this works out to determine your rounding. So 10 divided by, you're gonna go 80 cos 80. I got like 0.72, so let's go with that. And that would be in seconds. That's far enough as far as your rounding goes. So 2 decimal places would be sufficient. Next, you're going to determine what your vertical distance would be at that time. So you are going to plug in the 0.72 where you see the t. Well, what you also need to consider is the g. So because this was in feet, what we're going to be using is that g was equal to the negative 32 feet per second. I'm sorry, that needs to say 32. So we're going to use g is equal to, so negative 32 feet per second squared. All right, so we're going to start plugging into that formula. So I'm going to have y is equal to, and then we're going to have 80 sine 80 times the answer we just obtained, which was 0.72, and then plus 1/2, and then the negative 32, and then your times squared, which is 0.72 squared. All right, so you can type all that in. Actually, all at once too, because you know everything. 0.72 and plus 0.5 times negative 32 and 0.72 squared. All right, so answer would be totally okay if we round this. Let's go 2 decimal places again. I got 48.43. You guys agree? Okay, what would this be, feet? Yes. So in feet. All right, your next part. So same question, just part C. What is going to be the maximum height of the rocket? So when we did these were from chapter 8. The maximum height is when you had to take the derivative. So we're going to do the derivative of your y equals equation. Okay, so you're going to take your t back out. So your equation first was y was equal to, we had 80 sine 80 t, and then plus 1/2, and then negative 32, and then t squared, and then plus h, which is just a constant. So before you do the derivative, clean this up a little bit. So really your equation is y equals 80 sine 80t. So 80 sine 80t minus 16t squared plus h. Now you're going to take your derivative. And you can cross off these problems as well, so feel free to use that space if it helps. So the derivative of 80 sine 80t is just the coefficient in the front. So this is just 80 sine 80. So you just take the front part. Second part, the 2 comes down in front, gets multiplied by 16. So this is negative 32t. And the derivative of any constant is just 0. So now what I'm going to do is set this equal to 0 and solve for t. So 0 is equal to 80 sine 80 minus 32t, and solve for t. So I am going to use some of the space over here. So we have 32t equal to 80 sine 80. And then you're going to place that in the calculator again, and then use that answer to find your maximum height. So this is the time that the maximum height occurs at. It's not going to be your final answer just yet. All right, so you're going to go 80 sine 80 divided by 32. I got t is equal to 2.46 seconds. So that is the time at which the maximum occurs. So now you need to find the height. So to find the height, you're going to plug back into your original y equals equation. So last but not least here, I'm going to go y is equal to 80 sine 80. And then t is now 2.46. All right, so 2.46. And then I'm going to go minus the 16 and 2.46 squared. Okay, so that will be your answer. What do we get from this? Times 2.46 minus 16 times 2.46 squared is a height. So maximum height looks to me like 96.98. So 96.98, is that feet again? Yes. All right, so that is your answer. Okay, how's letter C? Again, it's been a while since you did that. So lastly to that question is part D. How long did the flight last? There's a couple ways you can go about doing this. You could set your equation equal to 0 to solve for when it hits the ground, or there's a faster way as well. This is when it reaches its maximum height. So if you think about this, it's looking like this as far as its projectile path goes. And we know that the halfway mark was 2.46 seconds. So essentially your time up is equal to your time down. So all you have to do is double that. So you could just remember this if you'd like. You don't need to support this algebraically. So time up equal to your time down. So just take that value and double it. So 2 times 2.46. And then you're done. Or again, you could work with the quadratic and do like quadratic formula, but it's kind of like, why bother at this point? You already have everything else, you know, above in all the different parts. So I have an answer of 4.92, and that would be in seconds. All right, so how is the projectile question, okay? All right, number 10, while I'm next to this, you may omit. I think there's only 1 or 2 left on this backside. Yep, 7 and 8 are all we're doing on this page. Number 7, we actually did work with this last week as well. So it says write the complex number in polar form. So polar form is going to have what variables to it instead of x and y? Yep, r and theta, good. So we're in rectangular currently, and we want to take this into polar, r and theta. So r is right on your formula sheet if you need it. And r is equal to the square root of x squared plus y squared. So I would go radical 3 squared plus the 1 squared. Again, I'm omitting the negative because it drops. So r is equal to 2. And then I find theta. So to do theta, I think about where this would get placed. So this is a positive x and negative y, so I'm here. So I'm going to do an inverse tan function of y divided by x. So we're going to type in the calculator second tangent of 1 divided by radical 3, which is equal to 30 degrees. So lastly, what you're going to do here is you're going to, do your subtraction to get your 4th quadrant angle. So I have 360 minus 30 equal to 330. All right, so answer in polar form, the abbreviated version that we used last week is 2 cos plus I sine of 330. Okay. How's 7? Is that okay? All right, so over to 8. 8 is really, really quick. When you are in parametric, all you need to remember is that x is equal to t. Therefore, y is equal to 3t minus 8. That's it. I wouldn't show any work on that. Okay. How are all of those, okay? All right, so over to day 4 content. And these I'm going to skip around a little bit because you guys literally just did questions like 2, 3, and 4. So I'm going to kind of focus on your concepts that are a little bit tougher instead. So number 1. Find each product, quotient, power, or root, and express your answer in polar and rectangular. So I first have a product. So what the rule is to do with these is you're going to take your radii and you're going to multiply them. And then you're going to take your angles and you're going to add them. So I'm going to go cis and I'm going to do theta 1 plus theta 2. That's a little formula if you want it. So first we should probably convert these. So I have 180 over 3, which is 60. And is this one also 60? Yes. So you're going to do 2 times 4, which is 8. And then cos plus I sine of 60 plus 60, which is 120. So that's your first answer. That's your polar answer. Now what you need to do is rectangular. So to do the rectangular, you're going to look at your formula sheet. And for rectangular, you're going to go x is equal to r cos theta. And you're going to go y is equal to r sine theta. And then you're going to take these and sub them in. So I'm going to have x is equal to 8 cos 120. And then you're going to have y is equal to 8 sine of 120. And now you have to remember these angles. So 120 degrees is a second quadrant angle. I'm going to do that up here. So I'm right here. I'm going to label ASTC always. So anytime you're doing your trig. And then I find my reference angle. In quadrant 2, I'm going to go 180 minus 120. So we're looking at 60. So x is equal to 8, and that's negative there. So negative cos 60. And then y is equal to 8, and then sine of 60 positive. Okay. So now's where you have to know these. So what is the cosine of 60 degrees? Negative 1/2. So this part is negative 4. Over to the other side. Now you need to know the sine of 60, which is radical 3 over 2. So this part is going to give me 4 radical 3 and then I. So your answer in rectangular is negative 4 plus 4 radical 3 I. And again, this is your rectangular answer. And your one above is your polar answer. So you needed both for these. Okay. Let's do a bunch more of those to kind of get that concept back in your head again. So the difference between A and B is now division. So instead of multiplying the radii, you are going to divide them. So the rule is R1 divided by R2, and then thetas, those are going to get subtracted. So I'm going to go theta 1 minus theta 2. Again, go ahead and convert these first. Pi over 2 is 90. And then pi over 6 is 30. So this in polar, this first answer, this one's fast. 6 over 4 reduces to 3 over 2. And then cos plus I sine. And 90 minus 30 is 60. All right, so there's your first answer. That's the fast part. Now you're going to take it the other step, just like we did with the question above. So now you're going to build all your rectangular. This is the part that takes longer. So x is equal to 3 divided by 2, cosine of 60. And then y is equal to 3 divided by 2, sine of 60. So 60 degrees is already in quadrant 1, so everything's positive. So cosine of 60 is 1/2, yep. So this one is x equals 3/4. Other side, y is equal to 3/2 times radical 3 over 2. And my y value is 3 radical 3 over 4, and then I. All right, so you make your answer look just like the one above. So just like that. All right, so I have 3/4 and plus 3 radical 3 over 4 plus u, I. And again, this is your rectangular. And up there was my polar. So if you're asked for both, that's what you want to make sure you do. All right, how are those two? Coming back to you a little bit? Okay, so next, letter C. So letter C, I need to convert this first to polar, just like the questions were above. So I am going to immediately find R and theta. So R is equal to the square root of x squared plus y squared So square root of 3 plus 1 would be square root of 4, which is 2. And now I find theta. So to find theta, you're going to think about where is this located. I think we already just did this one. So positive negatives here. So you're going to do in your calculator a second tangent of y divided by x. Yeah, we just did that one on the back, I feel like. So this is 30 degrees again. Again, the more you see them, the easier they kind of are to remember. All right, so now in quadrant 4, I am going to go 360 minus 30, which gives me 330. All right, so now I'm gonna write my answer in polar. So that's my first part here. So for polar, I am gonna have now 2 cos plus I sine of 330 raised to the 7th. So this is a power question. So now you're gonna look at your formula sheet. And if you look at your formula sheet and you go 1, 2, 3, 4, 5, 6 boxes down, you are looking at de Moivre's theorem. So you're looking at the one that says R gets raised to the n and n gets multiplied by theta. So again, this is what we refer to as de Moivre's theorem. And that is right off your formula sheet. So formula sheet. You may eliminate this question and use all that space as well. Same thing with this one. So what I'm going to do is take that 7 and essentially distribute it to both. So I do 2 to the 7th, cos plus I sine, and then 330 times 7, which we're going to need a calculator for both of these because these get large. All right, so 2 raised to the 7th is 128. Cos plus I sine. And then what is 330 times 7? 2,310. All right. What you're allowed to do is now find a coterminal angle with this that is in the range from 0 to 360 instead. So you're going to take 2,310 and start subtracting 360 until you knock this down to something between 0 and 360. You're going to have to do this a couple of times. I got 150. I'm going to make you a little note. You're looking for something coterminal. So I get an answer of 128 cos plus I sine of 150. That's your first answer. That's polar. Now you're going to go one more step, and we're going to write this in rectangular instead. So I'm going to use this space over here just because I'm running out. So to write this in rectangular, the same thing you did above, just a long procedure. I go x is equal to 128 cos 150. And then I go y is equal to 128 sine 150. And 150 degrees is quadrant 2. So you're going to do 180 minus 150, which is equal to 30. You're immediately going to label ASTC and kind of go from here. All right, so this answer, I'm going to have x equal to 128. And then this is going to give me the negative cosine of 30 because it's negative there. And then y is equal to 128. And then sine of 30, and that's positive. All right, so you're going to place into the left side cosine of 30. So cosine of 30 is equal to, nope, close though, radical 3 over 2. So x is equal to 128 divided by 2 is 64, and then radical 3. All right, over to the other side, the sine of 30 is 1/2. Positive because of quadrant placement. So y is equal to 64 and your I. So last answer in rectangular. I'm going to write it on this blank just because I have space there, but it's obviously not that answer. So negative 64 radical 3 plus 64i. And this is your rectangular answer. Involved, not hard, just lengthy. How's letter C? It kind of puts everything together for you. Now letter D, you're going to notice that your notation is different. It's going to have some aspects of what you just did above here too. Now for this one, what the question would say is find all of the roots. I need to include that part, sorry. Find all the roots. In this one, I'm going to let you just go polar only. Because otherwise, it's just a lot of tedious calculations, and that's how we left it on your final exam as well. So what I'm going to think about doing first is solving this. So I have x to the 5th would be equal to 32. And again, I need to make it look more like this to start it. I'm going to go plus 0i because you don't have anything there. So x would be equal to the 5th root of 32 plus 0i. And now you're going to rewrite this. This is your power over root rule. So if something is 5th rooted in the front, what you do is you rewrite this as 32 plus 0i to the 1/5 power. So what I need to do, because it's currently in rectangular, is we have to convert it into polar first and apply the same principle right here. So if I convert this into polar, I need r and I need theta. So r would be equal to the square root of 32 squared plus 0 squared. No, you don't have to show that. So r value is just 32. And then as far as theta goes, this should be very fast. So you only went over 32 because you have nothing on your imaginary axis. So your theta is just 0. So now I'm going to go up and I'm going to write it just like we did here, but raised to the 1/5 power instead. So your polar becomes 32 cos plus I sine of 0 to the 1/5 power. Now you're going to take it and distribute it just like we did above. So I'm going to go 32 raised to the 1/5 cos plus I sine of 0 times 1/5. So in polar, I get 2, and then cos plus I sine of 0. Now the question says find all the roots. So when we did this during the school year, you had to consider that this was a power of 5. So what you're going to do to finish this, it's very quick, is I go 360 divided by the power of 5. Which is equal to 72. And all you do is you keep adding 72 till you have 5 of these. So my first answer is 2 cos plus I sine of 0. And then again, I'll write you a little note there, add that. So there's 1. The next one, I'm looking for space, would be 2 cos plus I sine of 72. The third would be 2 cos plus I sine of 144. The fourth would be 2 cos plus I sine, what is that? 144 plus, what do we have, 72? 216, thank you. And I think you need one more. So your last answer in polar, so 216 plus 72 is 288. And then you're done. And I'm not going to make you do that rectangular as well because you would have to do this 5 times. And again, it's just tedious. It's not difficult, but it's a lengthy process. So here are your answers in polar. It's quick once you get it. And you just kind of do your addition there. So this is polar. Okay, you may cross off C. Let's see, what else do I have you? So basically on the front, you may cross off 5, A, B, C, and is there a D underneath this too? There must be. Yep, you may omit that one too. You don't need to do that one. If it's okay with you guys, I'm gonna save number 2, 3, and 4 because you literally just did that. So I think we're probably okay on that for now. We'll kind of go back to that when we have a little bit more time. And when it kind of leaves you a little bit and you need a refresher on it. So what I want to do is question 6. 7 you can cross off entirely. Same thing with 10. Those we are never going to do. I'm never going to do. All right, this whole first column, these all kind of work the same. So you want to find rectangular notation for the given polar. So formula sheet again. So rectangular again is x, y. Polar is r and theta. So you want rectangular on this. So rectangular means I'm going to go x equals 3 cos 150. And then I'm going to go y is equal to 3 sine of 150. So I'm going to have x equals 3. And now 150 degrees is where? Quadrant. Yeah. Again, you've got all these angles that you're kind of re-practicing again. So I'm going to quickly do 180 minus 150, which is 30. And then as a force of habit, immediately take your next step and label this so you don't forget it. So 30. So in quadrant 2, I'm negative. This is negative cosine of 30. This one is y is equal to 3, and then positive sine of 30. And then all you gotta do is plug them in, and those are your answers. And this one gets listed just like an ordered pair like it started. So this is 3, negative radical 3 over 2. So I have negative 3 radical 3 over 2. And then this one is y equals 3 times 1/2. So this one is 3 divided by 2. Okay. How's that type? Getting better again? Good. Letter B is the same exact thing. Same thing with C, but the only difference is you have to convert that first. So letter B, 5 times 180 divided by 6. Is that 150 again? I thought so. Yep, 150 again. And you're going to do the same exact thing as above, and we'll be able to use all those angles again. This will be fast. So x equals negative 5 cos 150. And then y is equal to negative 5 sine 150. Plug them in. I'm not even going to draw a triangle because you already have it above. So negative 5. And then negative cos of 30 was negative radical 3 over 2. And then this side, y is equal to negative 5. And this was 1/2. So your answer is 5 radical 3 over 2. And minus, oops, sorry, negative 5 over 2. All right, so no different than that right there. All right, so next, you're going to convert this as well. So I have 3 times 180 over 2, which is 270. So we're going to go x is equal to 2 cos 270. And then I'm gonna go y is equal to 2 sine 270. And 270 degrees is not a triangle. What do you need to refer back to instead? Yep, unit circle, which means you can essentially just type these right in your calculator. So we've got here 270 right off your unit circle. So it should be 0. Yep. So first value is just 0 for x. And again, I'll make you a little note here. This was unit circle. And then my next one, this is 2. And then sine of 270 is -1. So this is -2. All right, that's it for that one. Next. You're just going to take the notation, do the same exact thing. So, but this is not going to be listed as an ordered pair because obviously your notation has changed. So you have 6 cos 30 for x. And then you have y equals 6 sine 30. And hopefully these are getting faster. So 6, and then the cosine of 30 is radical 3 over 2. So this is going to give me 3 radical 3. Other side is 6 times 1/2. I just have to include the I on this, just like this. So my answer is 3 radical 3 plus 3i. So E, same idea. This one you have the condensed notation that you're working with instead. So break it apart. So 4 cos of 90. And then 4 sine of 90. And this is again referring to your unit circle. So this is a quick calculation right in your calculator if you don't want to sketch it out. This calculator is going to be faster. So cosine of 90 is equal to 0. And then sine of 90 is equal to 1. So this is 0 and then plus and then 4i. You obviously don't have to write the 0 in the front of this if you don't want to. Okay, so either way. All right, just a couple more for today. So I'm just going to finish this column. So letter F. So I want to take that one and convert it. This is not unit circle, I don't think. So 3 times 180 divided by 4 is 135. So your equation is going to say radical 8 cos plus I sine of 135. So now we are in quadrant 2, like this. 180 minus 135 is 45 degrees, ASTC. You don't have any multiple choice on your final. I know you guys haven't asked yet. So all of that is fair game for partial credit. Okay, so keep listing all that out. So I'm going to do here radical 8 cos of, again, 45 degrees here, but in this case is going to be negative. And then I'm going to do radical 8 and then sine of 45. So this is radical 8. Cosine of 45 degrees is negative radical 2 over 2. So on top, that gives me the square root of 16, which is 4 divided by 2. So that gives me a -2. Other side, I go radical 8. Sine of 45 degrees is radical 2 over 2 again. Numerators produce square root of 16, which is 4. 4 divided by 2 is 2. I'm going to go plus 2i. All right, so last two. You've got an equation on this one instead. So these two are different. So what we want to do is change this back to rectangular. So I see the 2 cos theta, I see the 3 cos theta. What you want to do with a case like this is you want to multiply everything by R so that you can do a substitution. So R times R gives me R squared minus 2R cos theta equal to 3R sine theta. And now you're going to look at your formula sheet and you're just going to replace your R's with X and Y instead. Then you're done. So R squared off your formula sheet would be equivalent to X squared plus Y squared minus 2. And then R cos theta, you just did that a ton above, is X. And then 3. And then R sine theta is equal to Y. And you can leave it like that. That's no problem because you've changed it to rectangular. So that would be sufficient right there. All right, so last letter H, and then we'll save the rest of these. But 10, I told you could cross off as well. We didn't do those with negative powers. All right, so letter H, I'm going to start and convert this first. So 5 times 180 is 900 divided by 4 is 225. So theta is currently negative 225. I like to work with positive angles, so I'm immediately going to add 360 to this. And that gets me 135. So 135 degrees is a quadrant 2 angle. So I go 180 minus 135 is equivalent to 45. Now theta off your formula sheet is going to be your inverse tan function. So we do tan inverse equal to y divided by x. So in your calculator, you're going to type in second tangent of 45 degrees. So that is equal to 1. You're going to remember ASTC because tangent is negative there. And then you're just going to substitute that into the left-hand side. So the negative 1 is going right up here. So negative 1 is equal to y divided by x. And then cross multiply. So your answer is that negative x is equal to y. Okay, so how do we feel on all the polar rectangular today? You guys feel comfortable? Okay, so tomorrow you do have a quiz on days 1 and 2 content. It's just 5 questions. I'm happy to go through a couple of those with you tomorrow before you take those, and then we'll finish some of these problems up as well. I will remind you that right on your Google Doc and right on Google Classroom, if you click, there are tons of extra practice problems that you have not yet done that you're welcome to, kind of cover up the answers and do them. A lot of these are very, very similar to what I'm going to ask you to do tomorrow, but only 5. Okay, don't forget about your parabolas, your circles as well. Questions, guys? And then assignments for this week, you've got those 2 deltas on days 3 and 4 content that you could certainly start, but those aren't concepts I'm going to quiz you on tomorrow.